Welcome back, everybody. This is Legit Lee back again with another video for you. Today I'm going to be showing you how you can actually make your own circuits. That's right, some PCBs on your 3D printer. So right now I'm using plotting, but it's still the same basic principle. So if you have like a vinyl cutter or a CNC tool like a Dremel or something of that sort, something that'll spin, has a little drill bit, chuck on it. So right now I'm using a plotter. I wanted to show you guys what I created so far on here. I'm going to be showing you my settings and everything that I've been using. So first one would be this right here. This is actually a circuit that I'm designing for something that you guys are going to be seeing here in the nearby future. I'm going to let you guys take a look at it. It's really small, really nice. It's using an Arduino chip right here. This little boxed area would be where the chip goes. It's off of the Adafruit's Trinket M0 board. Bought it straight off the Adafruit website. I was looking online at other websites, but they weren't all that great. eBay, for some reason, let me down. It was cheaper to buy it off the main website at Adafruit, so I went ahead and did that. But it may not look like anything to you guys right now, but in the nearby future, this is going to be something super amazing. So definitely stay tuned for this, because this will probably be the most intricate thing I've ever done on my channel, or at all, period, when it comes to these circuits and tech. Oh yeah, which reminds me, if you guys are into tech videos, whether it's DIY or reviews, definitely consider subscribing, because that's what I'm really all about. So that was just a piece of paper plotted out with a Sharpie fine tip, ultra fine tip marker that you can pick up like at a Walmart. And same thing for this. So I did it on paper first. The X you see right here is where I was trying to plot where my center point is on my bed. So if you guys see that X right there. And then once I got all my settings all dialed in, right now I'm going to let you know what printer I'm using. It's a CR10, not CR10, it's the Creality Ender 3. CR10 is from Creality 2, I'm pretty sure you guys would already know that. But so I'm using an Ender 3, super cheap printer. You guys will love it if you decide to pick it up, or if you haven't already. So a lot of people have, because it's super cheap and it's really accurate for printing. So I know for sure you guys would probably benefit from you watching this video. So once I got the settings dialed in, I started printing, drawing them out on some aluminum foil tape. So you can see right here, this foil tape is actually from Walmart. I just cut off a piece. You can get a huge roll for like $6, like roughly, I would say, with taxes involved and everything, from a Walmart. It's just like, I think it's from duct tape or something. I forget the name of the company that makes it, but it's aluminum foil tape. Now, I'll probably, if you're going to be making circuits, I would go with like one of the 3M's conductive foil, not aluminum foil, but copper tape. So I would use something like that, but I'm just testing it out on here first. So I have this one I printed out. This was the first one, but you can kind of see down here that this is actually a USB port over here in this corner. And you can see that the mounting, the top one is completely circular. I don't know if you guys can really see that or not on here, but the top part right here is actually completely circular, and then the bottom right here is kind of cut off, because where the settings were on my printer, like the position of the X and the Y, it wasn't completely centered right with the tape. So that was my first attempt, and then this one is my second attempt. So you can see right here down the bottom that I actually have all four circular hole for the mounting of the USB port that I need to do. So it looks really nice. I'm sorry if it's really shiny. I'm trying to make sure you guys can see all that. There we go. So I got this whole circuit drawn out. Now, if you're into DIY PCB making, you can probably etch this if you make sure you colored in all the circular holes, because what's going to happen is etching, obviously you guys would know, you just put in a solution, not this one, but like a copper one. You can actually do this with regular PCB boards made out of regular copper on the top and everything, the regular PCBs. You would sand it, clean it off with some isopropyl alcohol or paint thinner, acetone, and then you would just put in the etching solution. Since it's made with permanent marker, this Everything else will be obviously lifted away with the etching solution, and then whatever the permanent marker shows is where the metal will still be left at. So I'm going to go ahead and show you guys my settings. I'm using some free programs. You don't have to pay for any of this other than obviously the materials. But the programs I'm using is, first I'm using FCAM, FlatCAM basically. It's a free open source uh, PCB designer tool that helps me to plot out and map where I have to either drill or draw my PCBs. And then the other one is Easy EDA. That's a open source, not open source. It's an online open program. I'm not going to say it's open source, but it's an open program to anybody that likes to design PCBs. There's plenty of tutorials online on how you design these, and it's really simple. I literally only took like a day to figure out most of the information. But I mean, that's for me, and I actually am into tech really bad, so I don't know how long it would take for you. But for the most part, I feel like you would understand how to do it. But right now I'm using FlatCam and Easy EDA. Easy EDA, I made the circuitry board. I had to make a Gerber file for it, and then after that you export it out, because Easy EDA lets you export the file to a Gerber file, and then at that point you'll take that file, put it in FlatCam, and then you'll start designing your stuff. So I'm going to show you guys all the steps and tricks and tools it took for me to get to where I'm at right now. It took a few days to figure this stuff out, and if you guys have any questions or concerns about the situation, definitely comment down below. I'll be doing more videos like this, obviously, because I have something in mind for all these circuits that I'm doing, and this will work for any project you really have going on, as long as it's not a double-sided PCB. This I'm actually making a one single-sided PCB. I mean, you can make a double-sided one using FlatCam and Easy EDA, but I'm trying to make flexible circuits because I have a really interesting design in mind for a wearable circuit. So yeah, but this will work for flexible, regular, printed boards, whatever you decide to go with. And like I mentioned, I'm using the Ender 3, but you can do it on a CR10, ANET A8, obviously the Ender 3, an Ender 5, pretty much any 3D printer you want, as long as you know your coordinates and what you're trying to set it at. It can be tricky, but for the most part, you will be able to figure it out if you're into tech like I am. Anyways, enough talking. Let's just go ahead and get into the video. Okay, so let's get started. So the first thing you're going to want to do is go, obviously, to your internet browser. You're going to want to type in, well, actually you have to bring up two tabs here. Let's go to Google. Alright, so we have two Google tabs. First one you need to get is FlatCAM. FlatCAM. Now, go here. I haven't done this on this computer yet, so I'm going to go right along with you guys. Go download. And then right here is bit buckets where you're going to start at. I'm using Windows 10 64-bit, so get what you need for your system. And I'm going to go with the Windows 85 Explorer. This is for 32-bit, but it works for 64. So we'll just get that, set save. And then this tab, you're going to want to go to Easy EDA. Go into here. Now you can download the center, but I just use the online information. And I have it set up through my Google account, kind of, so all I have to do is just go here. And then for the login, all I have to do is go to continue with Google. I already should have my information and hopefully have my files here. There it goes. So you see me up over here in the corner. And so we're going to go to open. Right, yeah, Easy EDA. Oh, not that. Hold on. Where is it at? Maybe it doesn't save for all the other ones. I don't know how this actually works. Project, there we go. So I was doing a flexible Arduino circuit. I don't know which one this is. I have a test. Master, new project, flexible. I guess the test one. Let's go ahead and bring up the data sheet. So here you can see I have this whole circuit design and easy EDA here. So this is the ATSAMD21E 118A-MU. What that is basically the trinkets, which I'm going to show you real quick, processor board, processor chip. So let's go here. And we'll go to trinkets. I don't need to versus this. Let's just comment that out. M0 is the one you're looking for too. They have two different variants. I think the first one is an older model, so I wouldn't go with that one. And let's just do images so I can show you what it looks like. So right here, this Atmel circuit board is this right here. It shows you the pinouts and what they correspond to, digital pins and all that stuff. Right here I had originally a this chip right, where is it? Here. This is a NeoPixel LED, and that's where this was at, but I didn't put it in my circuit because I just don't really need it. So I have a regular push button switch. Actually, I think this is the old one. I have made two. So I think that one, no, that's right, this is it. Because this is actual push down button switch that I have as well. So it's just like this one right here. Anyway, so once you get the schematic and all that, you'll just do here, I believe is where my PCB draw out is. This is the one I'm drawing out right now. So here you can see this is the circuit board. So this right here. And then the data, the digital pin outs and inputs here, and then this is just if you zoom in you can see the information VCC. Then we have ground connections, ground, VCC. These are digital pins. They'll tell you what VCC, that's basically voltage, and then ground and the data pins. So and the analog pins. So you have right here is the LED circuits and the resistors for those. So like these right here are the LEDs that show power on and like loading and stuff like that. And then these are the resistors that go to those LEDs. So I have those on here as well. So when I desolder everything off of this board, I can put it onto this board right here. And these right here are just some diodes that I have to keep the power from going where I don't want it to go. So this is diode connectors. Then over here you can see this is the USB port right here. These are the data lines, and that's where it mounts to. So just like this one right here, matter of fact, it pretty much is the same exact concept for the most part. And then right here, this is just a flick switch, on-off switch for the power, which if you plugged in a one of those LiPo batteries, 3 volt, you can plug it in, and then this will be the switch for it. I would wire it correctly. Anyway, so once you have this set up, you export it. So you're going to go to Gerber right here, fabrication, I believe. Yes, I could check for DRC, but it's not going to be anything. It's not going to read any errors because there isn't. So if I wanted JLC PCB to make my board, I can actually have them do it, and then, you know, only pay $2 for like 10 of them or something like that quantity. But I don't want that. I'm going to generate the Gerber file. So we're going to download and generate it. Yeah, we can just save it as a, just download it as a file manager. Then we're going to extract it. I'm just going to put it in, let me go to documents. I'm going to have to set up my own stuff here real quick. I'm sorry guys that this is taking so long. I didn't want it to take long, but I'm basically following along with you guys because I haven't, like I said, I haven't done it on this computer yet. So we'll just type in Gerber files. I'm sorry, I'm typing kind of slow. I'm eating something at the same time here. This is a ridiculous video right now. I probably should have waited. You guys are probably gonna hate me. It's fine. Hate me all you want. Alright, let's go hit that. So that should be done. And then, now that we're done with that, this should have been done downloading. So we'll go ahead and open this up. That's for the FlatCAM. Here, this is my stuff. I need to, hold on, it's gonna treat it as a Windows system application. Yeah, treat it as a Windows system application is good. There you go, we're installing it. Hit OK, accept, yada yada yada, go, I do not, so I guess I'll create desktop, why not? Okay, yes, install. So now that we've done that, now granted, when we exported this out, it created more than just one file. It has layers on top of layers. You got top, bottom, all that good stuff. But we're only using the top layer because we don't need nothing else. At least I don't anyway, because I'm making a flexible PCB circuit. So, and we're gonna finish, launch. I just wanted to show you guys this. Let me just move over. So we have this launched, and now we're gonna kind of bring this up a little bit so you guys can see both of the information here. So I'm gonna go to File, New Project. So we're gonna do Open Gerber. Then we're gonna go to Documents because I saved it in there, in Gerber file. And then we're doing our top layer. Where is it at? God, bottom, top layer GTL. Okay, so we hit Open. And there goes the same schematic that we just created, right? So you created it on Easy EDA for free. You download this free program, put it on here for free. And then what you're going to do is you're going to go to, you have to click the project you selected. So originally you weren't clicked on it. Until you highlight it, you won't be able to mess with it. So I'm going to show you why. So say I don't click on it, we go selected. Oh, hold on. Well, it's doing it now, but before you actually had to click on it. I think it's only when you're clicking the other files. You'll see in a second here. Anyway, so the first thing I'm going to do right now, since I'm using a Sharpie, it's a ultra fine tip, so that's going to be a 0.2 millimeters. But I'm drawing it out, so I'm not cutting it out. And you know what I mean by that is these lines right here can be cut out. So we're going to do the outside, right? But we're drawing it right now, so we need to do the inside. So you're going to go negative 0.2. So you'll put negative 0.2 for the drawing out. I'm only doing one pass because we're drawing it out. And then right here, I set my overlap for 7.07. Then I put 5 zeros after that. And you're going to want to go here too because it's in millimeters, so you have to set the millimeter options and project options too. So once you do that, it's going to say set the units, you hit OK. And you may have to redo this really quick. I should have done that first, that was my mistake. So 0.02. Point is a 0.2. And then 5 zeros, 7 and 5 zeros. And then we're going to offset this. Now I am using an Ender 3 like I said, so my Ender 3 and pretty much your guys' Ender 3 too will have these same coordinates. So if you want to copy this, go right ahead, but you still need to dial in your settings for your stuff. So not every Ender is the same and not every printer is the same, so you need to calculate and figure out where exactly your stuff is. So I calculated a certain amount, which I'm going to show you here in a second. Alright guys, I'm back. So now we're going to start setting your offsets here. So like I said, we're using the Ender 3, so my offsets, I figured out that it would be my vector offset, my X is 118, so we're going to change the first code, the first number from 0 to 118. You can leave the dot right there, it's fine. .0, and then the Y is 129. So the X is going to be 118 millimeters in, and the Y is going to be 129 millimeters forward. And then once you hit offset, this is going to move all the way out here somewhere in the space that we can't see yet. We have to like zoom out and zoom back into the area that it's going to be at, because right now we're at the 0 position right here, and this is 30 millimeters, this is 60, so we're almost 65 right here for how big my board is. 65 millimeters by, I want to say 20 or so. 20, no, maybe like 40 millimeters. Wait, 10, so this will be 10. Yeah, like 20, 21-ish, around there. So now we're going to hit offset, and now you see it moved. So we have to zoom out, and it's all the way up here now because we're in the 100 range or whatever. So we have to zoom back over here, and now you can see it moved 118 this way, and obviously 129 forward, so it's in that space. So now we did that. That was the only offset that you had to do. And since we have our isolating information set up properly, -2, 1 for the passes, how many times it's going to draw this out? It's just going to draw one line for each area. It's not going to keep going over the same areas over and over again because we're not drilling it out. We're just drawing it right now. And so we're just going to hit generate geometry. So now it shows the lines here. You see we got it all drawn out here. Those red lines are inside the position, and we're drawing this information out. So now we're going to go back. Now originally when we went to project, there was only one there. So once you hit generate geometry, it creates this new ISO information. And that already you're going to have to go ahead and join geometry. So you go to edit, join geometry right here. And then that will create this combo for both of these because it's got the information for both. And then once it makes that combo, you hit on combo. Because see, if you go here, it's going to go back to this information. If you go here, it's going to go into this information. If you go here, it's going to go into its own information. So we're in the same area. So we're going to do, we selected it. We're going to have to go ahead and hit 2. We're going to do, because this is the cutting depth. We are not cutting, so we don't need to go below the homing position. So when you home your X and your Y, you're at the 0 point for your printer. And at that point, you can disable, or the G-code will disable how far down your Z-axis will go. So it can go into the negative range, so below 0, which you don't really want to do because then you're just dragging and messing stuff up. So I found that 2 millimeters would be the best for it, for me anyway. If you're trying to keep your pen close to the bed as possible, but not actually touching or drawing on it, and so we don't have to worry, it'll run faster. You don't have to worry about it going up and down so many times where it takes longer for it to draw out the code. So this is based off speed and accuracy that I've been trying to set for. And then our travel is going to be 4, so it's going to go from the home position up to, and then it will move over, and then drop. It'll move over like, I think it's 4. It goes up 4, I believe, and then it drops down 2. That'll keep right here anyway. This will keep the actual nozzle from hitting your bed and scraping against it. So then when you go to travel, right, and travel would be for when it moves from one line. So when it starts drawing out, say, this line, then it has to jump over to this individual line. It's going to lift up 4 millimeters and then drop back down another 4 millimeters to draw this out. I mean, that's what I set mine for, is 4 millimeters. You probably could set it for 3, but I try to do 4 because I just try to double whatever it is that I'm using to go down with. I just feel like it works better for me. I don't know. It's up to you guys if you want to go lower, but I just choose 4. And then my feed rate is actually the speed of how fast it's going. I tried 200, it was a little too slow. I tried 300, still a little slow. 400 is, I feel like, a good medium. And then 500, I feel like, would be your fastest. But don't quote me on that because it's up to you how you want to set this information. Because if you're using a spindle, like a Dremel cutter tool bit, then obviously you may want to set it for a slower rate, or if you're using a X-Acto knife cutting blade like the ones you can use for a plotter, I mean for your like if you want to draw out, say, I don't know, letters, or you trying to draw out the circuit board or something, and you have one of those diamond cutter bits. It's like, it's not a diamond cutter bit, it's a metal blade that you can get for the those vinyl cutters that you can use to make out lettering for like t-shirts and stuff. It cuts vinyl, so you can get one of those and attach it to a printer too. So any of those things will actually help and draw out anything for you, or cut anything, or whatever you want to go about it. So I'm just doing this for the Sharpie, so I'm at 400 for that. And then remember, your tool diameter size is going to be the tip of the Sharpie, or at least it is for me anyway. And so right here will be 0.2 for the tip, and then we're going to do generate the G-code. Now, if it was below negative, say you're cutting negative into here, or even 0. If you cut a 0, it's going to highlight all these lines blue originally. But we don't need that because we're trying to draw above this. So it's going to show some blue little lines because it's going to show where it's going to be drawn out at. But it's not going to show these lines turn in blue. So if you see the lines turn in blue, that means you're going below your cutting depth. You're basically cutting into it. So we're going to hit generate. And then here you have it. It generated the information. So you can see here these blue little numbers and everything on here. That's it generated for you for the cut information, or the drawing information. So then you go to combo. So once you did that, you generated the information you wanted. So now you're in combo CNC. So what that is it's going to draw out, you're creating the G-code finally for your printer. So there is a trick for the G-code. Matter of fact, if you don't already, which I don't here on this computer, I'm going to go ahead and grab that real quick while I'm on here. I'm sorry if you guys hear yelling in the background. My sister's like yelling at her kid or something. I don't know. Everybody's yelling back there. I'm sorry that this video is ridiculous. I don't want to stop and have to keep recording because my kids are about to come back soon. So, you know, you got to take it how you get it, really. This information is valuable. I didn't find nothing like this on here, so I had to do a lot of work to find all this stuff out. Anyway, you're going to want to get Notepad C++, or Notepad++, I mean. If you don't already have it, which, I mean, I should have had this. It's just I didn't. I don't know. I just was never really worried about it, but I needed it now. It makes more sense to have it. So I'm going to download this, install this. Super easy to use tool. Anyway, so while we're waiting for that to download, so now we're in CNC, right? So now we're going to click on that. We're going to go selected, and then you can type in the name. I'll just leave it to whatever it is. Now, here, you can type in the beginning part of the G-code. Now, originally, this is for mostly CAM projects, like CNC router cutters and stuff. So, you're going to want to put a G28 code in here. G28 is basically the homing code. So, anytime your printer starts up, your slicer software, when it's slicing your 3D design, it already implements the G28 command for the first part, because it's always going to home from the whatever position your stuff is at to 0 to start the print before it starts. So I like to do that for here, so I'm going to type in G28. Actually, no, I'm not going to type it in yet. I'm going to leave it blank because I want to show you guys what I mean. So we're going to generate this G-code. Let's just go ahead and hit export G-code. And then I'm going to make another, this is Gerber file, so I'm going to go to documents and create another folder real quick. New folder. And we're just going to type in G-codes. I'm going to space that out. There we go. Okay, so hit enter. Now we're going to jump in there, type in PCB, test 2.3. I'm going to type in G-code just to be safe. .G-code. And then we're going to hit save. And there you have it. So there is another program you can get, which a lot of people already would have. It is a different type of slicer program, I believe. It's a repeater host, I think. I forget how you pronounce it. Repeater, whatever. I don't know how to repeater host. I'm sorry if I'm saying this name wrong. These guys be creating some kind of weird names for stuff. Anyway, this one actually can read G codes just like Akira can. All these other, donating, blah blah blah. I'm not gonna donate anything. Continue, download without donation. There we go. Anyway, so that downloaded. We have it right here, I believe. Is that right? That should be it. Make changes. Okay. Oh no, this is Notepad++. We definitely need that because this is gonna help show stuff. There we go, and we run it. Okay, so that's Notepad++. We don't really need to run it because it's installed. I don't know what happened to repeater firmware. No, I don't care about all that. What is it? Did it download yet? What's going on here? Okay, it didn't download yet. Come on, save file. There we go. So while we wait for that, now that we downloaded or exported out the G-code, it's going to G-codes, right? So we can go to our files, and then you're going to go to documents. At least mine is documents and G-codes. And then you can see right here, I have simplified 3D, so simplified 3D can read it. And then so can repeater host. The reason why I'm using repeater host is because that's free. Simplified 3D you have to pay for. So that's why I'm waiting for that to finish downloading. Matter of fact, now that it's downloaded, let's go ahead and open that up. There we go. So yeah, you're going to be downloading a few programs, guys, if you're going to try to do this all from scratch like how I am on this computer. So make sure all the slicers, okay, good. Okay, yeah, we're good on that. Finished, and done with that. And then, so now that we have that done, we're waiting for that to finish up, which will be pretty quick. We can go here, and then you can right click and open this in Notepad, right? So you can see right here, this is the code that we just generated. So these are all the position and coordinates on your bed that the pen is going to draw the information out. And it's going to start off with a G21, G90, and 94. So right here, this is the feed rate, the speed at 400. Now, originally Tech2C, I believe his name is, or yeah, I think that's the name of his YouTube channel. He was showing that you had to put a I think a G0 code right here in front of it for it to actually read that speed, but you don't have to. I guess either Merlin had an update or the FlatCAM had an update. Either way, you don't need to actually put a G in there. It would actually do that speed for you without causing any issues. And then right here you see this will be where our Z lifts up 4. Automatically, FlatCAM has your nozzle or your x-axis, your z-axis lift up 4 to move the nozzle up, and then it will move over to the coordinates that we placed, and then it'll go back down. But see, we're going back down 2, so we don't have to worry, and that will be for every code in here. So if you go down, you'll be able to see, if I can just find that information. Okay, right here. So it goes back up 4. Once it's done drawing out all the lines, it goes back up 4 and then goes down 2 again because it moves over to the next coordinate for the other line that it's doing. So that's why I was saying it lifts up to move from one line, then moves to the spot where it needs to do the second line and drops down 2 and starts the second line. So, but at the top, you notice that there's no homing. There's no G28 command. Now you can type it in here manually and it will work. Or instead of having to do that or even use this exactly, I mean, you can use it if you want to check the G code and all that. But if you don't want to worry about using that, you don't really have to. Not for this part, but you may need it for another part. I agree.
repeater, her server. Oh, I don't really need the server, so I'm not really too worried about it, but it is fine. Anyway, so what I was trying to get at, when you go to FlatCAM, you can actually type in the G28 command right here. This will be pre-penned to G-code is actually, no, I'm not doing this. What? Fine, history. I have to read the policy stuff. Add printer. Okay. God. I'm sorry, guys. I know this is such a dragged out whatever. But, I mean, that's life. I don't know. You guys just have to deal with it. I'm sorry. So, yeah. No, we don't need it. Yada, yada, yada. Hurry up and finish, man. There we go. I think that did it. Let me see. Well, we're not gonna use repeater host then, because they don't want to do the installation without making me do all this. Please wait while it's set up. Oh God. Close window. Oh God. All right, hold up. Task manager. Let's go ahead and close this out. There. Anyway, back to what I was saying. So right here, this pre-penned to G-code is actually going to be your beginning part of your G-code, and then you have an end part. So you can have this be your beginning and this will be your end, just like how they does for Kira. Kira has an end script and a beginning script, which I can show you really quick here if I can find Ultimaker really fast. Come on, where are you, stupid Ultimaker? Crap, there we go. Alright, so Kira. Or Ultimaker Kira. So bring that up, I'm going to show you what I mean. So that way you guys can kind of get a good understanding of what all this actually pertains to, because the codings are what's really necessary for any laser engraver, CNC, 3D printer, whatever. It's all about the G-codes. You can type up a complete G-code yourself if you know the exact coordinates or everything, but that's why they have slicers. A slicer just slices the information and the coordinates for where it needs to print at, basically, or design at. So if you go into settings and go to configure, printer, here we go. Go to printer, and then actually we can do, let's just add a printer, because I have a CR under 3, so not custom. Let's do other under 3. Here we go. We'll add that one, and then the board and everything is going to change. You can see right here. It should have shown like a little whatever, but I guess it's because I don't have the latest Cura version or whatever, but it doesn't matter. So we're going to go into printer settings, right? Or manage printer, I mean. And then right here, the machine settings is going to show you the start and end G-code right here. So if you look at this, it's going to show an M04, M104, M4, 140. There goes the G28 to home all axes before it does anything else. Resets extruder, moves the axis up and down, yada yada, to prime the nozzle and all that. It gives the information of what it does, and then the end code turns off the heater and the heated bed, moves your bed forward, all this extra stuff. So you can customize G-code however you see fit. So right here we're gonna do G28 command, right? So you've seen right here there is none. So if I put G28 here, G28, you'll see that come up. So if we export the G-code again, let's just change this one to, actually, you know what, I'm just going to use this. I mean, this is open, so I'll have to, I don't know if I can reopen it or not. Maybe I should just change the number. I'll just change the number. We'll change this to 2. Let me rename this. 2.2 and then 2.3. And I'm going to type in .g-code. I do this just in case. I don't trust the my computer to automatically generate the .g-code file. It's weird. I don't trust it. I'd rather type it in so I know it's there. There. So we typed in .g-code, hit save. Now we have a new one, right? So we can go here. There it goes. We're going to open with Notepad again. It's another program. What? This file has been modified in another program. Do you want to load it? What are you talking about? Oh, yeah. Okay. Because we just changed it. Now we have to open up .2 because we just made a .3. So we have to do that. Okay, so this is .2 right here, 2.2 that we just first made because I changed the name. And then you see there's no G-code right there, but over here, there goes the G28 command. We didn't type that in until we typed it in here onto our FlatCAM information. So if we decide to change and then add a moving G-code at the end, say our X is going to be at a 0 position, so you can hit I think it's G01 or 001. I can't really remember all the commands for movements. I think it's G01, then X0 to home it to the 0 position, and then you can hit Y, and you can push your stuff forward 34 millimeters. That's right, 234 millimeters to the front. Then you can hit export G-code again, and this time you can just oh yeah, before I show you that, so that end code will actually be at the bottom of your stuff because it's at the end. So right here you see originally is going to G00 home command to the X and the Y to 0 position. So if we do it here, so it was a 01. It's a 00, not a 01, so I have to go back to that. So go back to cam. Let's cancel this. Hit G00. And now we can export it. And then we'll upload it to this one. Hit save. Yes, I know we would like to replace it. And there we go. So let's reopen, we want to reload it, and then there you have it. The last end command, G0, and then we have the Y34. We can actually just do, if we're going to home 0, we can just do the 34 already. Just the G00 or G01. It probably should have been 1 because we're moving. We're not homing or anything. I got to double check that. But you don't actually have to do it this way. Originally, what I did, I just typed in G28 for this, and then what I did, since it's already changing position, now you can type in either G00 or G01. You have to find out which one it is. I just don't know at the top of my head right now. But you could just type that in. Since it's already homing X and the Y, this would just, you can just remove this part and just have it be Y234, which will bring the bed all the way out to the front for you. Or you can just type it in right here because you're already printing. So if you just type in Y, this is what I did on mine. I just typed in Y234, saved the G-code to SD card, popped the SD card in, and got rid of this line. Don't need it. Or like I said, you could put it in here if you want to. Put 00. Or 01, whichever one it is. But make sure you have the space in between so it knows what it's trying to do and where the next step is. But so yeah, we can do that, get it all set up, and then all you have to do is just hit save. So I left it like this for mine, so it would home everything, move everything to the right coordinates. Let me just go all the way up here. So we have G28 for the first command. It's moving at 400 millimeters a second, and it's going to be bringing the Z up 4, then moving it over to the X position that I set from the coordinates to start the print, move down, and then it starts printing the first line. And then after the first line is done, it's going to calculate all this. Okay, there it goes. I just passed it. Okay, so then after the first line is done, which usually is this one on the outside, I believe is when it started, or this one, I can't really remember. I think it was this one, matter of fact. Either way, it will lift up 4 millimeters off of whatever line it is. So say it's this one, it lifts up, then moves over to this position on this end over here, and then drops back down 2 millimeters right here, 2 millimeters onto this plane, and then starts printing out on this area. So it moves all the way back, all around, all that good stuff. So that's basically it in a nutshell, guys. I mean, I know I talked a lot, and this video is probably dragged out way more than it needs to be. But like I said, I'm trying to give the most basic person the ability to do this, because all these guys are really smart, and they love to, you know, design things and show you guys stuff, but they don't show step by step, and they're not really helping you out and trying to figure it out exactly. They just expect you to already know this. I didn't go to college for this, and I don't know everything there is to know about this stuff. So anything I find out from a beginner's perspective, I want to show the beginner this way of me going about it. So anyway, so you'll hit save. Let me just go down, make sure everything is set up right. Hold on, let me just scroll down. Come on. There. So we're at, yeah, good. Okay, so then we will hit save, right? And that's it in a nutshell. Your G-code is finished. You can exit out of that. You can exit out of FlatCAM. You can exit out of here because your G-code's already finished. It's this one. You'll put that. All you have to do is drag and drop it onto the SD card and not have to worry about it. Cut out of here and here and there and there. And then that's it. So then we're gonna go right now over to the printer. I'm gonna show you guys how it works, and also the guy that I got the stuff from for CNCing, I believe, it's a Thingiverse, if I'm not mistaken. Ender 3 PCB maybe, or something like that. Let me just type it up. Ender 3 PCB. It should be like, or a plotter or something. Had to have something to do with maybe like plotting. I can't really remember. The guy was making it. I think I Google searched it. I'm trying to find it because I know you guys can benefit from this information. PCB DIY, I guess. PCB milling with a 3D printer. Yeah, that makes sense. So yeah, we use Tech2C. He was showing how to do it in FlatCAM, but he didn't. He showed how to do it with this, which is a great video. I mean, it helped me out a lot too. But if I could find it right, I don't know if I was just looking straight up for FlatCAM stuff. FlatCAM. Trying to show you guys the stuff that I've seen. Let's just go to images. This is how I search for a lot of the information I'm like looking up. Now this is Tom's from Tom 3D or whatever. He's on YouTube, super big guy. Super big on YouTube anyway. And I like his stuff, but he didn't really show all the information either. That's what I'm saying. Like, I know they don't want to make their videos long and watch time and whatever, but if you guys don't want to listen to any of this, you can skip ahead to the other part of this video for the 3D printer. I'm just trying to find out about this. Here it goes. I think this is it. Him. So this is actually, I'm not going to show all his stuff, but I think he has a website right here, if I'm not mistaken. Yep, this is it. So you go down, 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 down. Okay, so he was showing how he got his board. This is not easy EDA. He's using a free PCB maker, and then he's using FlatCAM. He had to flip the board because this is the bottom side. You see the words are backwards, so he flipped it around to make the words forward because this is the bottom side of his board. And then he talks about the G-code and the information and then how to set it up, but he doesn't show how he set it up how I set it up. He's just showing it his way, his version, so I had to kind of go off of his stuff then go off of my stuff. But this is kind of weird because like he said he had to space out the X and the Y because Marlin doesn't do it for some reason if you're using the Merlin firmware for your printer, which most printers use. But I didn't have that problem. I didn't have to space out my X and Y information from each other like how he's showing here. See, like right here you see Y, but over here his is all spaced out because he had to do it manually. Then he shows he could show it in repeater host and everything, and you can see. I don't think I've seen it in my repeater host, but it doesn't matter. I mean, it's working obviously. So I just want to show you guys this information right here because of the fact that it helped me out a lot. So good guy. I like his stuff. He did a good job on this. So now that we're done with giving you where I got most of my information from, I'm going to go ahead and get this onto a SD card, and then we're going to pop it in this printer, and I'm going to show you how it works. Okay guys, so right now I'm showing you guys how to set this up on your bed. So I have this tape right here. Like I said, got it from Walmart. It's a lot of aluminum foil tape. And cut out a piece already with some scissors right here. Just some regular scissors, nothing crazy or fancy. And then I got this right here. This is a 3M sticky tape. I mean, you can use Scotch tape or whatever kind of tape you have just to tape it to the bed because you don't want, obviously, this to move around and you don't want to peel off this backing just yet. So I'm taping the tape, literally. So we're going to make sure that we have it set up properly. And we don't have to talk about the axes or positioning because you already already know how that went with the last part. Well, I just talked about it. Okay, that one has too much, so we just need to back off a little bit. This part's the tricky part because you want to make sure you have it set up right. Come on. Right there should be good, and we just push it down. Try not to touch that so much. I mean, if you do, I mean, it's not a bad thing. Just make sure you clean it off with some alcohol or something. I'm not going to because I'm not worried about it. I know it's not going to do anything. I haven't really touched this part. I just touched the tape itself for the most part. But definitely try not to touch the center because you don't want to cause any issues. There's oil on your fingers, so you don't want to have that on top of your PCB that you're trying to draw out here. So we have that flat, and then if we wanted to check with this, sorry about that. If you want to check with this, that's pretty much centered. Matter of fact, let me get the other one. Alright, this is my finished product one, so this is good. All I gotta do is just put it where I know it's supposed to be at for the X. And okay, so that's a little off, I believe, right? Yeah, it's a little off because I could see through this to the. So that one, this has to come up just a little bit. So we can just peel it back up. Okay, so there we have it. That is centered. I'm just push this down a little bit here. Keep the tape from coming up. And see, it doesn't matter about the tape because it's just holding this piece of tape down, so you don't actually have to worry about all that. But I don't know if you guys can see through that or not, but I'm going to peel this piece of paper up so you kind of can see that it's pretty much dead centered on there for the most part. It's a little, yeah, it's actually really good. So now what you're going to do, now that you have everything mounted down, keep all that down, you're going to push this back. You put in your SD card. So you have a little SD card. I just kept the one that came with the printer. So you just pop that in, you push it, make sure it clicks.
So then you're just gonna go to your controller. So you're gonna hit enter, change SD card or initialize the SD card, whichever one you're gonna be doing when you get in there. Hit print, and then you'll go down. I have it set as PCB test 2.3. The reason why is because I did 1.9, 1.2, 2.1. Like I done a lot of these just to see where it's at. So I'm at 2.3. So I go back, print, go to 2.3. So it's gonna home. And I had to set that up manually in the G-code, the G28 command. Then it's gonna move over, down, and there you go. So now it's starting to draw it out. See right now it's drawing out the lines. I have this printed piece right here that connects the Sharpie. I 3D printed it from somebody else that was doing something like this. I'll leave the link down in the description below for you. And then I just have this rubber band on here to keep it up against here because I noticed that the piece doesn't have any way of actually fully mounting other than like clipping onto the back part of the bracket. And then once it's done printing, I also added another part of the G-code to actually make it to where it's going to pull the bed forward after it's done doing everything, so that way you can pull your PCB off without any problems. I think it was for the x-axis at the end of the code, when you generate it, it'll be all the way at the bottom. It shows Y for 234. See, there it goes. Now it's pushing it forward. Just move this back so you guys can see. And then it still homes the x-axis without any problems. And there you have it. So that is a fully drawn out PCB for whatever projects you're going to be making, and you're actually using a 3D printer to do it. I mean, I'm pretty sure you guys seen plenty of videos, but I didn't see anybody actually fully talk about it, like their steps and processes to get to this point. And I've done multiple tries here, like I don't know how many times I tried to get everything going, but I finally came up with a solution. It took me about 2 days to figure this out. So hope you guys are liking the video. Please like, subscribe, let me know what you think, and definitely comment below if you have any questions or comments, or just want to ask how I was getting here, or for what I plan on doing with stuff. Anything you guys want, definitely link down below for where I got this piece over here, which I'm going to show you real quick. So this will be on Thingiverse over here. There we go. So this right here is from Thingiverse. You guys could print this out yourself and attach it to the back of this bracket without any issues. My name is Legit Lee, and I'm signing out.